Good morning, student. Today I am going to explain some question from practice set 2.5. In previous video we have completed up to question number 4. Here I am going to explain the question number 5. Now what is the question? The sum of the roots of quadratic equation is double their product. Find the value of k if the equation is x square minus 4kx plus k plus 3 is equal to 0. One quadratic equation is given, one condition between the roots of the quadratic equation is given. From that you have to find out the value of k. Now what is the equation is given? X square minus 4kx plus k plus 3 is equal to 0. Here I write equation x square minus 4kx, this last term k plus 3 is equal to 0. If we compare this quadratic equation with standard form of the quadratic equation, that is ax square plus bx plus c is equal to 0, then we get a is equal to 1, that is the coefficient of x square, b is equal to minus 4kx minus 4k, that is the value of b, and c is equal to third term, that is k plus 3. If we consider alpha and beta are the roots of given quadratic equation, now what is the condition given in the question? That is sum of the roots, that is alpha plus beta, is equal to twice the product of the roots, that is 2 into alpha into beta. This is given, here we mention as equation number 1. Then we know the relation between the roots of quadratic equation and the coefficient. And what is the relation? The sum of the root is given by minus b upon a is equal to minus value of b, here we find minus 4k, here we put minus 4k, value of a is equal to 1. Negative negative, it is positive, here we get 4k. This is equation number 2. And next relation between the products of the root alpha beta is given by c upon a is equal to value of c, here we find k plus 3, a is equal to 1, k plus 3 upon 1 is equal to k plus 3, equation number 3. Now from equation 1, 2 and 3, sum of the root alpha plus beta, that is 4k, is equal to 2 times alpha into beta, this is k plus 3 in bracket k plus 3. Here we solve the equation, 4k is equal to 2 into k, 2k, 2 into 3, here we get 6. 4k, here we transfer the 2k on the left hand side, become minus 2k is equal to 6. Subtraction of this, that is 2k is equal to 6. Therefore k is equal to 6 upon 2 and k is equal to 3. In this way, here we get the value of k is equal to 3. I hope students you understand this question. Now we see the next question, question number 6. Now what is the question number 6? If alpha and beta are the roots of quadratic equation y square minus 2y minus 7 is equal to 0, find the value of. First it is given alpha square plus beta square, and second it is given alpha cube plus beta cube. Now solution for this question. First we write the given quadratic equation, that is y square minus 2y minus 7 is equal to 0. Already equation given in the standard form. Compare with the standard form of the quadratic equation, ax square plus bx plus c is equal to 0. Then a is equal to 1. Here we get b is equal to minus 2 and c is equal to minus 7. We know that the relation between the roots of the quadratic equation and their coefficient. Then sum of the roots alpha plus beta is equal to minus b upon a is equal to minus value of b is minus 2, that is minus 2, minus minus become plus, that is here we get the answer 2. Then alpha into beta, that is product of the root, is given by c upon a is equal to value of c, that is minus 7, here we put minus 7, value of a is equal to 1, minus 7 upon 1 is equal to minus 7. We have to find out the value of alpha plus beta square. First we write this identity in this form. Okay. Now what is the identity? Alpha square plus beta square is equal to alpha plus beta whole bracket square minus 2 alpha beta. Okay. Remember this identity is equal to alpha plus beta The value of alpha plus beta here we find out is 2. Here we put the value 2. 2 square minus 2 times alpha into beta. The value is minus 7. Here we put minus 7. Now solve this. 2 square, this is equal to 4. Negative negative become positive. 7 to the 14. 4 plus 14 is equal to 18. Here we get the value of alpha square plus beta square is equal to 18. Then in this question you have to find out this is the second. Alpha cube plus beta cube. You have to find out the value of this. Alpha cube plus beta cube. Now what is the identity for this? Alpha cube plus beta cube is equal to alpha plus beta whole bracket cube minus 3 times alpha beta in bracket alpha plus beta. This is the identity. Now is equal to, now what is alpha plus beta? We find that is 2. 2 cube minus 3 times alpha into beta, this is equal to minus 7. Alpha plus beta, that is equal to 2. Here we put all this value. Okay. Is equal to 2 cube. Value of 2 cube is equal to 8. Now negative negative. The product is positive here. 3 7s are 21. 21 2s are 42. Here we get 8 plus 42. This is equal to 50. Therefore value of alpha cube plus beta cube is equal to 50. Now our final answer is, first answer alpha square plus beta square, here we find out 18, and alpha cube plus beta cube is equal to 50. Okay. Then after this question, here I take question number 7 1. Question number 7, first question. What is the question? Find out the value of k. In this question also you have to find out the value of k. If the roots of the following quadratic equations are real and equal. One condition is given, but what is roots of these quadratic equations are real and equal. Using that condition, you have to find out the value of k. Now for this, first we write down this equation. 3y square plus ky plus 12 is equal to 0, already given in the standard form, and we know how to compare, and we have to find out the value of a, b and c. From that, here we get the value of a is equal to 3, coefficient of y square. Value of b is equal to k, that is the coefficient of y, and c is equal to 12. Then we find out determinant delta. Determinant delta is equal to b square minus 4ac. Here we put the value of b, that is k square minus 4. Value of a is equal to 3 and c is equal to 12. Now solve this equation. Here we get k square, negative sign here, and multiplication of 4 3s are 12. 12 into 12, that is 144. Here we get the value of discriminant delta is equal to k square minus 144. Now what is the condition is given in this question? Condition is the roots of these quadratic equations are real and equal. And we know the condition for real and equal roots, that is delta is equal to 0. Value of discriminant is equal to 0 in condition of real and equal roots. Therefore here we write delta is equal to 0. We already find out value of delta, that is k square minus 144. Here we put k square minus 144 is equal to 0. Here we get the one equation. We solve this equation, we can write k square is equal to, we transfer 144 on the right hand side, it become positive 144. Then taking square root on both the side, then k square become k is equal to, while taking the square root here we have to take plus and minus. This means you will get the value plus or the minus. Square root 144. Therefore k is equal to plus minus square root of 144, that is perfect square number, and its square root is 12. Therefore there is 12. Therefore k is equal to 12 or k is equal to minus 12. This means here we get the value of k 2, that is 12 and minus 12. I hope student you understand this question. Now what is homework for you? From practice set 2.5. Question number 1. This is one activity is given that you have to complete, filling the blanks like that. And question number 7. Already we have seen the first question. Second question is homework for you. In this way, here we completed the practice set 2.5. This is all for today. Thank you very much.